Okay, hi. This section 2.8 is about derivative as a function. So remember that we discussed the slope of the tangent line to the curve at the given point x equals a as the derivative at x equals a equals the limit as h approaches 0 of f of a plus h minus f of a divided by h. But now if we we use the same formula, we basically let a be x. Okay, so we plug in x for a. This formula will become f prime at x. We also say f prime of x equals to the limit as h approaches 0 of f of x plus h minus f of x all divided by h, provided that this limit exists. So this is now the derivative of a function of x. So is the derivative as a function of x. So you read it as f prime of x. Okay, so f prime of x. So for example, you are given a function f of x equals x squared plus x, and you are asked to find f prime of x. So when we look at the formula that we're going to use, the formula of the derivative, so what do you need? This is what you call the quotient. Okay. You have f of x plus h minus f of x all divided by h. So we need f of x, which we are given. We need f of x plus h, and we have to take the difference, f of x plus h minus f of x all divided by h. After that, then we take the limit as h approaches 0. So let's look at this. F of x is given to us as x squared plus h. So what we need to do is find f of x plus h. How do you find f of x plus h? You go to the function f of x, you replace x by x plus h. So you put x plus h here, there, and there. So it's going to become f of x plus h equals to quantity x plus h all squared plus quantity x plus h. So you can write this as such. Now, so you then going to expand quantity x plus h all squared, which is x squared plus 2xh plus h squared. And then when you remove the parentheses, because you have plus sign, you get plus x plus h. So this is f of x plus h. So then we want this difference. So you have f of x plus h minus f of x. It's going to be equals to, this is f of x plus h. And f of x, we know it's a given function x squared plus x. So when you do this difference, you have f of x plus h minus quantity f of x, quantity x squared plus h. Make sure to distribute this negative sign to both x squared and x to make it negative x squared minus x. So when you reach this stage, then you can cancel like terms with opposite signs. So you have x squared minus x squared is 0, x minus x is 0. So we say f of x plus h minus f of x is going to be equals to 2x plus h, 2xh plus x squared, and then plus h. That's what's remaining. But then we need to divide the difference by h based on the definition. So when you divide this by h, we get, and then we apply the limit as h approaches 0. So on the numerator, we see in every term of the numerator, we have h. That means there's a common h, so we can factor out one h. So after you factor out an h, you're going to have a 2x left from the first term, h from the second term, and then 1 from the third term. So that you can take that h and then divide by the h at the bottom. So after division, you get the limit as h approaches 0 of 2x plus h plus 1. To take the limit, basically we let x be 0 to get 2x plus 0 plus 1, which give us a function 2x plus 1. So we say f prime of x equals 2x plus 1. So the derivative of the function f of x, which was given to us as x squared plus h, equals to 2x plus h. You see, you get another function. Sometimes we write quantity x squared plus h prime, it gives us 2x plus h. So then this f prime of x is like a formula for all slopes of the tangent line to the curve at any point on the curve. For example, when x is 0, the slope of the tangent point that is going to be tangent to the curve at x equals 0 basically is going to be, we go to the formula 2x plus 1, we plug in 0 for x, we get 1. So the slope is going to be 1. Now you can compute the slope at any point on the curve. They give you all the slopes. So the second example is about, again, here they give us a function f of x, which is square root of x plus 1. They want us to find its derivative. Again, this is the formula of the derivative as a function formula. So we are given f of x. Now we need to find f of x plus h. So what we do is we go to f of x and then replace x by x plus h. So f of x plus h equals the square root of x plus h plus 1. We take the difference of the two. So f of x plus h minus f of x is going to be then square root of x plus h plus 1 minus square root of x plus 1. All divided by h, and then we apply the limit as h approaches 0. So this is a case where we're going to, before we do this, we're going to conjugate the numerator and the denominator. We're going to multiply the numerator and the denominator by the conjugate of the numerator, because we have the square root sign. The conjugate of the numerator is just to make the numerator positive here. So the conjugate of the numerator is the square root of x plus h plus 1 plus square root of x plus 1. So we're going to multiply this fractional expression, both numerator and denominator, by the conjugate of the numerator. So when you take square root of x plus h plus 1 minus square root of x plus 1 times quantity x square root of x plus h plus 1 plus square root of x plus 1, what will happen is going to square the first term. You get x plus h plus 1. You square the second term, you get x plus 1, and then you put the negative minus sign between the two. So think of this as a quantity a minus b times quantity a plus b, which must give us the difference of squares. So a square minus b square. So make sure to introduce this minus sum to both x and 1. So you're going to have negative x minus 1. And then you look for like terms, but opposite sign. So you get x minus x is 0, 1 minus 1 is 0. So the only thing that remains on the numerator is h. And then because at the bottom you have h, so you're going to simplify h, 1h. So h divided by h is 1, h divided by h is 1. So you get to 1 in the numerator. Denominator, you get square root of x plus h plus 1. I mean square root and then plus square root of x plus 1. And then you have the limit as h approaches 0. So when you let h be 0, what happens is 0 goes here. So you get the same thing at the bottom with addition. So square root of x plus 1 plus square root of x plus 1 is 2 square root of x plus 1. In the numerator you still have 1. So you end up with the derivative of the function. The given function is 1 over 2 times the square root of x plus 1. And that function is what you see here. So you can find with this is like a formula of the slopes of the tangent lines to the curve at any point on the curve. Okay. Thank you for watching.